In the first lesson video for this topic, I looked at the theory about static electricity. And in this lesson video, we're going to look very closely at one important way of demonstrating static electricity through the gold leaf electroscope. We're going to not just see what happens, but we're going to focus strongly on what is happening with the charge inside the electroscope. I'll start by trying to draw one. We have a metal plate at the top, which we will use later to interact with the electroscope. Attached to that is a metal rod, which comes down inside this box. The box is there for support and to block wind, etc. On this metal rod, we attach a gold leaf. A gold leaf is simply a very, very thin sheet of gold foil. It is metal, so it conducts electrons, and it is very light, which means it can move quite easily. It is attached at the top, but free to move lower down, so if it does move, it will rise up like this. That's the electroscope, so the first demo to try is to get a balloon and rub it on some hair, which transfers electrons to the balloon, making the balloon negatively charged. Now we bring the balloon near the metal plate and the gold leaf rises up. Take the balloon away and the gold leaf drops back. Next, bring the balloon in, see the leaf rise, then touch the metal plate with my finger and the gold leaf drops. Remove my finger first, then move the balloon away and the gold leaf rises again. Magic, or at least science so advanced it appears like magic. Or I could explain things to you. Actually, try yourself first. Pause the video and have a think about it. In fact, even better, there were 2 demos, so maybe rewind and watch the first one and think about that, then watch the second one and think about that. Have a try. This is the pause. Hopefully you did try that, so let's go and have a look at those 2 demos again. For the first demo, let's step through it. The negatively charged balloon was brought near the metal plate. This will repel negatively charged electrons in the metal plate, pushing them down the metal rod and also into the gold foil. Since the metal rod and the gold foil are both negatively charged now, they will repel, and this causes the gold foil to rise up. That's the electroscope demonstrating static charge. Removing the balloon allows the electrons to redistribute, to spread back out in the metal, so the gold foil is not repelled by the rod anymore. Before I move on, did you notice my careful use of language? I tried to use actual nouns to describe things rather than using the word it. I also referred to the charges, so the negatively charged electron. And you might be thinking, well, what's the point? Everyone knows an electron is charged. But the point is that in my description, it was the charge that was important, not the particle that was carrying it. So, how did you do with your descriptions? And do you need to rethink your second description for the second demo before moving on? So, in the second demo, the balloon was brought in, pushing the electrons down the rod and raising the gold leaf like before. I then touched the metal plate and the gold leaf dropped. Clearly, I was neutralizing the gold leaf. Since only negatively charged electrons can move, this must have happened by negatively charged electrons flowing to my finger and probably down to earth. I was earthing the electroscope. I took my finger away, and after that I removed the balloon. Removing my finger broke the connection to earth, so the electroscope is isolated again. Removing the balloon allowed the electrons to spread out since nothing was pushing them around anymore. The electrons in the electroscope are free to move again, but it already lost some because my finger took them away. So, as the electrons redistribute, we end up with a small positive charge spread evenly throughout the electroscope. The total amount of positive charge has not changed, but the total amount of negative charge has dropped. This means the gold leaf and the rod are both positively charged, so they repel, and the gold leaf rises. It is important that you understand this example, but it's also important that you can apply these ideas to other examples that you might come across. When you do try to describe things like this, use nouns rather than the word it, refer to the charge rather than just naming the particle, and remember that it is always and only the negative charges that move.